JWST found galaxies that shouldn't exist. When the first deep-field images arrived in July 2022, astronomers expected chaotic infants but found massive, mature galaxies shining from the cosmic dawn. Researchers begin calling these galaxies universe breakers because their very existence threatens to break the standard model of cosmology itself. The lambda CDM model, the foundation of modern cosmology, is now under scrutiny. The central paradox is, these galaxies sit at redshift 10 and beyond, a snapshot of the universe less than 500 million years after the Big Bang. Yet, they look far too massive and too mature to have formed that fast. The stakes are high, and the possible endings are three: our instruments are fooling us, our measurements are wrong, or the lambda CDM model needs a total rewrite. The central paradox is a detective case, and the scientific method is the forensic procedure to solve it. Before anyone rewrites physics, every mundane explanation must be eliminated. Could these be nearby dusty galaxies masquerading as ancient ones? By splitting the light into spectra, teams confirm the telltale Lyman break signature. These galaxies really are sitting at redshift 10, 13, even 14. The distances are real. Spotlight the record breaker. Jade's GSZ 14-0, observed just 290 million years after the Big Bang. This galaxy is unexpectedly luminous, surprisingly large, and already showing signs of rapid, efficient star formation. The record breaker is just one of dozens of candidate impossibles. Independent teams, JWST, Source, Glass, using different methods keep finding the same thing. This is not one glitch. It is a population. The early universe appears to contain up to 100 times more stellar mass than lambda CDM simulations predict. This means the problem is now too big to dismiss and too consistent to ignore. The stakes are high, and the possible endings are three: our instruments are fooling us, our measurements are wrong, or the lambda CDM model needs a total rewrite. The central paradox is a challenge to the very foundations of modern cosmology. Theory 1, the twice-as-old universe. Physicist Rajendra Gupta proposes that tired light plus evolving constants could stretch cosmic history to nearly 26 billion years, dissolving the paradox by giving galaxies more time to grow. Theory 2, dark matter never existed. If Mon-style modified gravity replaces the invisible particle, galaxy formation rules change entirely. Theory 3, early dark energy. A brief burst of mysterious energy in the infant universe could have accelerated structure formation, letting matter clump into massive galaxies far ahead of schedule. Theory 4, the humblest explanation. Maybe the universe was simply better at making stars than we assumed. Feedback-free starbursts and pristine gas clouds converting mass into stars with near-perfect efficiency. Each of these ideas is a possible solution to the central paradox. And remarkably, physicists are excited rather than frightened, because every option leads somewhere astonishing. Whatever the final answer is, this moment represents science working exactly as designed: doubt, replication, debate, a live demonstration of why the scientific method remains humanity's best tool. NASA's Nancy Grace Roman Telescope and Europe's Euclid mission will survey thousands of square degrees of sky. Deeper JWST programs will push toward redshift 20, enough data to settle the question definitively. It was a century ago. Edwin Hubble looked up. He saw the universe expanding. It changed everything. Then came the Big Bang model. It was elegant. It explained the cosmic microwave background. It explained galaxy distribution. It explained accelerating expansion. It became the crown jewel of physics. But light takes time to travel. Every telescope is a time machine. We look back. We see the past. The James Webb Space Telescope has an infrared eye. It sees the infrared universe. It lets us watch the universe's childhood directly. Generations of simulations predicted this. They painted a picture. A dark, quiet era. Then, tiny proto-galaxies flickered to life. They were small. They were messy. They were slow. They took billions of years to grow. Some people spent their whole lives here. They refined the model. They knew the early universe was mapped out. It felt personal. It wasn't just academic. It was their life's work. They were confident. But the data arrived. It showed something different. The expected picture was wrong. The early universe was not quiet. It was not small. It was something else entirely. Let's talk about the scale. A galaxy has billions of stars. That is a lot of mass. The universe was young, less than 500 million years old. According to the laws, this was impossible. Gravity takes time to work. Gas takes time to cool. Stars take time to form. Everything takes time. But the universe showed up too fast. It defied the physics we knew. We trusted this model for 100 years. It explained everything we saw. It was beautiful. It was precise. It was the foundation of modern cosmology. But now, the foundation is shaking. The James Webb Space Telescope is different. It looks at the infrared spectrum. The visible light is blocked. The infrared gets through. This allows us to see the first stars. They are hidden in the dark. Deep within the sterile glow of NASA's Mission Control, a team of astronomers watches in stunned silence as raw data streams from the James Webb Space Telescope. Their screens flicker with distant light. Yet something feels profoundly wrong. These galaxies shouldn't exist. Not yet, not so soon. The universe's first light should still be flickering like a dying ember, not blazing like 1,000 suns. The first question is always the simplest. Could these be imposters? Nearby galaxies, dusty and mislabeled, hiding in plain sight, but the data doesn't lie. The telltale redshift signatures, stretched light from ancient epochs, are unmistakable. These galaxies are not just distant. They are old, older than the universe's own infancy should allow. Enter spectroscopy, the cosmic fingerprint test. By splitting light into its spectral rainbow, astronomers uncover the chemical fingerprints of these distant worlds. The Lyman break signature, a hallmark of early galaxies, confirms their age beyond doubt. These are not tricksters. They are real, and they are wrong, according to every model we've ever trusted. Then comes JWST 14-0, the galaxy that defies all logic, discovered just 290 million years after the Big Bang. It shines with the luminosity of a mature galaxy, one that should have taken billions of years to form. Its stars are already born in clusters. Its core is dense with ancient matter, and it's growing. Too fast, too soon. The universe's first skyscraper, erected in the blink of an eye. But JWST 14-0 is not alone. Independent teams, JADES, SEWERS, GLASS, each using different methods, keep uncovering the same impossible truth. Dozens of these universe breakers lurk in the early universe, each one a puzzle piece that doesn't fit. The question isn't if these galaxies exist. It's why they exist at all. The universe's first chapter seems to have been rewritten in ink. By the way, if you like this discussion, don't forget to subscribe. There are many more interesting topics coming up. Light bulb. The numbers don't lie either. Simulations predicted the early universe should be a sparse, messy place. Tiny proto-galaxies struggling to coalesce. Instead, JWST reveals a cosmos teeming with stellar mass, up to 100 times more than expected. The discrepancy isn't a glitch. It's a crisis. Our understanding of the universe's infancy has been built on sand, and now the foundations are shaking. The scientific method demands rigor. Before rewriting physics, every possible explanation must be exhausted. Could these galaxies be nearby? No. Their spectra confirm their ancient age. Could they be artifacts? No, they appear in multiple independent surveys. Could they be misinterpreted? No, the data is consistent, overwhelming, and undeniable. The only remaining question is, what does this mean? The hunt for answers begins. If these galaxies are real, then our models must be wrong. But before jumping to conclusions, the detectives of the cosmos turn to the one tool that has never failed them. More data, more spectroscopy, more surveys, more patience. The universe, it seems, has one last secret to reveal, and it's about to rewrite the story of everything. Meanwhile, back on Earth, a team of researchers poring over the raw data notice something peculiar. The early universe isn't just full of these galaxies, it's efficient. Stars are forming at rates that defy explanation. The gas clouds aren't just collapsing. They're exploding into stellar nurseries with alarming speed. The universe, it seems, was born with a hunger no one anticipated. The implications are staggering. If the early universe was this active, this alive, then our simulations were missing something fundamental. Maybe the first galaxies weren't just born. They were forged in a way we've never imagined. And if that's true, then the entire story of cosmic evolution might need to be rewritten from its very beginning. The scientific community divides. Some cling to the old models, insisting that these galaxies must be anomalies, mistakes in the data, outliers that will vanish with more observations. Others, however, are already whispering about the implications. If the early universe was this different, then perhaps the late universe is too. Maybe the rules we've spent lifetimes studying are only half the story. One thing becomes clear. This isn't just about fixing a few numbers. This is about trusting the universe. For decades, cosmologists have relied on simulations to predict what they'd see. But now, the universe is showing them something entirely unexpected. And in science, when the data contradicts the theory must bend or break. The investigation has only just begun. But one thing is certain. The universe has always been a puzzle. And now, it's handed humanity the most complex one yet. The question isn't whether we'll solve it. It's whether we're ready to accept that the answer might change everything we thought we knew about the cosmos, and ourselves within it. Deep in a quiet office, a physicist scribbles equations on a blackboard. The chalk leaves trails of dust in the dim light. Rajendra Gupta stares at his calculations. The numbers whisper a radical idea. What if light itself loses energy over cosmic distances? The universe could be twice as old. Gupta's theory merges tired light with shifting cosmic constants. Time stretches like taffy. If true, galaxies gain billions of years to form. The paradox vanishes in an instant, yet critics call it a desperate fix. Could tired light really explain everything? The next theory shakes the foundations of dark matter entirely. What if it never existed? Mon theory suggests gravity behaves differently at cosmic scales. No dark matter needed. If true, galaxy formation rules change. Early giants become natural, not miraculous. But dark matter explains so much. Could we abandon it without consequences? The third theory introduces a mysterious force. Early dark energy could have sped up formation. A fleeting burst of energy could have kick-started massive galaxies in the cosmic dawn. But where did this energy come from? No one knows. It's a mystery within a mystery. The fourth theory is the simplest. Maybe the universe was just better at making stars. Feedback-free starbursts and pristine gas clouds could have turned matter into stars with astonishing speed. No dark energy, no exotic forces, just a universe that did its job exceptionally well. But which theory is correct? The debate rages on, and the universe holds its secrets tight. Physicists are not frightened. They are excited. Every theory leads to a new frontier. The night sky has always been humanity's oldest book. Its pages whisper secrets older than empires, older than language itself. For centuries, we thought we understood its chapters. The Big Bang, the cosmic microwave background, the slow dance of galaxies growing over billions of years. But then, the James Webb Space Telescope turned its golden eye toward the cosmic dawn and saw something impossible. Galaxies that shouldn't exist. Built from starlight we thought took billions of years to assemble. Scientists scrambled to explain away the impossible. But every excuse collapsed under the weight of evidence. Now, we stand at the edge of a new frontier. The next chapter of cosmology is being written in real time. NASA's Nancy Grace Roman telescope will survey thousands of square degrees of sky. Its mission, to settle the question once and for all. Europe's Euclid mission will map the dark universe with unprecedented precision. Its data could rewrite the rules of gravity itself. What if the universe is older than we thought? What if dark matter doesn't exist? What if stars formed faster than we ever imagined? Each answer could reshape our understanding of reality itself. But here's the truth. No matter which path we take, humanity gains nothing but wisdom. We trade a comfortable story for one that is truer, and that exchange has always been the essence of human progress. The universe owes us no simplicity. It is sending us a puzzle across 13 billion years of space. And the most exciting chapter of cosmology may be the one we are writing right now. What is the dark truth behind this event? Share your theory below and watch our next investigation. Hi everyone! Quick reminder. Subscribe for high-quality daily content. Sparkles don't miss out. Subscribe today for exclusive content tomorrow. Wrapped gift.